Okay guys, so in this video we are going to talk about REST and REST API design, so let's get into it. So first and foremost, let's define REST, and then we will just touch on some tips and tricks that I can share with you for how to think about designing a REST API. So REST, or Representational State Transfer, is a very popular architecture for web API design, and the basic idea of it is that you have a domain object or a model of some sort that holds a certain, like a data structure, and you use the HTTP verbs, or the methods if you will, to express the things that you want to be able to do with that model. And basically the idea is that you can do a get to get the information, or you can do a post to create new information, or you can use, say, put to update existing information, and you can use delete in order to remove information. Those are the base concepts in a RESTful. I will just keep it at that level because the semantics of exactly how to do this can get really nitty-gritty, and if you are like zealous about the exact definitions of what is REST and what is RESTful, we can have that discussion for a very, very long time. But I'm a pragmatist, so these are the base concepts that I find to be most relevant in everyday work, and this is the sort of things that you will find out there in the real world for the most part. So, to touch on something first and foremost, I'd like to say that when it comes to REST, you should know that each company does it, well, let's just call it RESTful-ish or RESTful, because there are tons of situations where you may have to break different like core rules of how to make something RESTful. But we're going to touch on the things that I've found to be almost a constant in all the REST APIs that I've built so far, and just some useful tips about how to do that actually. So let's walk through it. So first and foremost, we have our little server here where basically all we do is that, hey, we connect to Mongoose and we create this little like connection to the database, and we also listen on port 3000, and we have a little bit of an unhandled rejection handler here, but that's not all that important. Anywho, let's look at our application. So the app itself is fairly simple. What we have here is a bunch of endpoints, and this entire REST API, all it's about is to handle a user. And the way that, as I said before, that you think about RESTful APIs is that you have a data model, a model that represents an entity within your system, a user, for example, and all the information that is associated with a user. And the idea here is that you put a web server in front of your database and you allow the client to make controlled requests to your database, because you should at no point ever let your client connect directly without any type of filter in between to your database and just make queries and updates as they see fit. And that's where this idea of RESTful comes in, where you put just this web interface in front of your database, and you allow for a lot of flexibility, but you enforce certain rules, and we will go through these now. So for example, I want to allow my client to get all the users, or basically list all the users, and this is that endpoint. And I want to be able to create a user, so this is that endpoint. These two are a little bit special, and we will talk about those a little bit later. And then I want to be able to provide an interface for getting a specific user, and that's this endpoint here. And then updating a specific user, and finally deleting a specific user. And then we will talk about error handling as well, which, you know, we'll just touch on that a little bit later. But this is the basis for a RESTful API. As you can kind of see here, we have the delete, the put, the get, and the post. All these methods are in the HTTP standard, and will work on anything that can talk over HTTP and consume JSON, of course, because right now you don't have to have JSON as the transfer protocol, but it's fairly standard at this point, I would say. So let's walk through the specifics of what this actually is all about. Let's take a look at this little client that I have, which is called Postman, and Postman is basically just a REST client that allows me to, well, it's not just for REST, but it's something that I use for network communication and just kind of getting away from having to use a browser for everything. So let's, for the sake of argument, say that I have this endpoint here, which we saw earlier is like going to and getting all the users, and the common thing to do here is to just have the plural version and just have that be our endpoint. So I click send, and I get back an empty array. Makes sense, right? Because if we look at the code here, we see that what's going to happen is I have a bunch of stuff here. We will touch on that in just a moment. And then I have this service that is called list users, and all it does is that it returns a bunch of users and returns the response. Great. So I don't have any users, therefore there's an empty array. Cool. With me so far. And then let's say, for the sake of argument, I want to create a user. Well, then I will have to specify in my headers that my content type is application JSON, and in my body I will send, just send a request here. So I'll click send, and my response is going to be this data structure here. So I have a first name of foo and a last name of bar, and this other stuff we will talk about in just a moment. If I now go and list my users, as we can expect, I see that, all right, I have all my users, which is great, and that's about it, really. Now, this is the base functionality, but let's just create a few more users. Let's create 3 of these users. And let's just click send again. And here we see that we have 3 different users. Cool. So now comes the first tip here. So one of the most common things that you will do when you have a REST API is to provide some type of listing of a domain model or a domain object. Now, one of the problems with that is that you want to be able to allow the user to specify, or rather the consumer of your API, to specify what it is that they actually want. And I have 3 practices that I follow here, which I have found to be very useful. So by default, you don't have to do this if you don't have this use case, but it's very common that you have it. I think that you should provide an interface for an offset, a limit, and fields. And we will touch on this, on what exactly that means. So the idea with RESTful is that you keep your URLs clean as possible, because you want to be able to express the state transfers or the state management that you're doing through without a lot of specific endpoints. You don't want to have one endpoint to do each thing. And what I've found to be much more useful is to simply use queries to express these common mutations on the response, because what I want is not to change a behavior on the server. I want the response to be a little bit custom. So if let's say, say limit, for example. So I want to be able to express a limit for how many of the users I actually get back. And this is very common when let's say that you just want to show the first thing. Let's say that you want to, we have a top 3 here, but let's make that a top 1. So I can do something like this, and I can say limit 1. And now I only get 1 response back. Or say limit 2, and I get 2 back. And then finally limit 3, and I can actually limit to the top 3 if my data set was even bigger. So this is a very common and very useful thing, because in order, imagine if you had millions of users, it wouldn't make much sense for you to return all those users in one request. It would be very heavy, it would be extremely unperformant. So in order for you to be able to just create a subset, limit is a very useful thing to add to your endpoint. Now, limit is useful, but one thing that is also very useful together with limit is the offset. And the offset, as we saw here, is something that it's very similar. Now, we will go into this in just a moment and kind of look at exactly what this means. But the offset idea is that you can express how many from the data set that you want, or which one you want. Let's say, for the sake of argument, that I set a limit of 1. Okay, so I have a list now of 1 element, but I also want to change the offset, because I want to not get the first thing that's in the database. I want to get the second thing, or in this case the third thing. Then you notice that the ID is changing here. So I can get the first thing, the second thing, and the third thing, or rather the third user. And with this offset and the limit, I can actually support pagination, which is very common, where you will say that you have a user-facing application, that like a UI or something, That's very common, and you have these different tabs because you want to show one page with the top 10 hits, and then you have like sections where you can click the second tab and you'll show the next 10 and then the next 10 and so forth and so forth. And by using limit and offset, I can actually say that, okay, I'll set my limit to 1, and then I will just grab the first thing, and this is going to be page 1. And then I can get the second thing, it's going to be page 2, and so forth and so forth. And you can do this with an arbitrary amount of data. You can set limit to 100 if you will. Well, it depends on how much you want to actually return in a response, but this is a very easy way to support pagination. Now, make sure that you think about, this is just a little thing that I do, which is like I have some type of hard-coded or like some upper bound for limit, because as I said, it's not a good thing if you by default return the whole database to your client if it's not an internal system that you control. If it's a user-facing thing, you may find that malicious users may exploit this, so try to set some reasonable limit, like an upper bound or something like that, just to be safe. And then finally we have the concept of fields. And fields is something that I find to be very useful, especially when you have really large models. Now this model is super simple, it's super small, and it's actually very uncommon that you have this amount of data. Like usually in production, and like enterprise development, you can have documents that are like massive, and you may have documents that have sublists. Imagine if our users had followers, and then you have a array of followers, which is another set of users, and they have users, followers, and so forth and so forth. I mean, it can get really, really large very quickly. So something that I like to do is to provide the fields property, or the fields query. So if I say fields and I say something like, I want to just get the ID here, then I can actually express to my server that, hey, I don't want all that information, I just want the ID. And then I can just do something like this, and I can grab the ID and the first name. So you can actually allow the client to specify exactly what they want from that data structure. And finally, I can say, let's do last name as well, just to be extra clear. So now I can actually just get a subset of the data that I'm looking for. And this is very useful if you want to exclude information in the response and just keep your network communications a little bit more lightweight. Cool, so these are the base queries that I like to provide. I have others as well that are for more specialized cases, but these are my bread and butter ones. I use them quite often when, of course, when it makes sense to do it. And it's fairly easy to support. But let's go on to looking at getting a specific user, for example. Let's grab this ID here. And let's just change this ID to that, and then let's do a send. And now I got a specific user, as we saw earlier. So in the first one, I'm simply listing things, which is very common, and now I'm getting something specific. But I can, of course, just do this. I can do fields, and I can do a last name. I just want to get the last name of that person. So you still, I support this on everything that allows me to get the actual model. So then we have putting things. In other words, we are updating something, and the red thread here is that when you're posting something, you post to just the /users because you're creating something from nothing. But when you're updating something, you require an ID. In other words, we have to have this in order to make an update. So if I'm now, let's say that I wanted to change this person's first name to Foos instead, and I do send, and now that person is no longer a foobar, but foosbar, just as an example. And in this scenario, you can add queries to this as well, so you can add fields last name for the response, but I usually don't. You can, but it's a personal choice. I just wanted to show you that when it comes to put, ideally what the mindset that you're going for is that you have an already existing model of some sort that you want to update. Now you have to be careful with this. This is something that is very important. You have creating something, like posting something or getting something, depending on what information that you have to always think about the consumer of your data. Is there information that you don't want to expose to that person? Like an example is that you may not want to include certain information in your response. So if you're now we just have a first name and a last name, but imagine if we had, say, password or something like that. When you're returning things, you should always consider what information you're sending back. Never try to remember that certain information is more sensitive than other information, and you also have to remember who is consuming this information. If you have a user session and you can validate that the user who is accessing your data is actually the same user who created it in the first place, then maybe you can actually say send back an email, but you should never send back another person's email to, like this in this listing function here. It would be very, very bad if you sent back a list of users and you include their email and their password in that response. That's not great. So always remember what you're sending back. And the same thing goes for updating something. So let's say that you wanted to update a user. Now notice that I'm actually extracting the fields specifically. I'm not just grabbing the whole body and just updating. I'm extracting the first name and the last name because these are things that I feel are safe, and I'm allowing my client to actually update about this user. And this is the difference here, guys. This is a rule, or rather a restriction, because if I would just allow the user to proxy through everything directly to the database, they couldn't do a lot of damage to my models. But by doing this, I can actually enforce that it's only the first name and last name. And I could add even more rules to this. I could say that they have to have a certain length, or like they have to be in a certain format. I just want to show you the idea here. Never ever allow a update to be done on something just arbitrary. You have to really think about what properties are okay to actually update. I mean, imagine if I did something like this. So I could allow the user to try, or just in theory, I would allow like my client to update the model ID. That's not something I want. Or if, just think about it. That's all I'm saying. So I'm grabbing the user ID and just calling this service here. We can look at that logic in just a moment. And then finally we have, of course, so we have our put, and then we finally have a delete. Let's actually just grab this ID here, like so. And let's remove that, like that. And if I now call delete, you see that delete is now actually set to true here. It was false, but it's set to true. Now, why am I doing that? Well, this is a personal preference that I have, where you can do something which is called a soft delete. Well, a soft delete is basically that you do this, that you have a value that represents that you have deleted something. You could have a boolean, may not be the best thing. Maybe you wanted to have a timestamp instead, like a date when something was deleted, because if you do that, you can always be sure that you have, like, you can represent that the information has been deleted by the client, but you don't have to actually remove it from the database. That way, you can simply keep it around if you ever need that data later on. But you can still, of course, just filter out that information. So let's say that I just remove all of this stuff here, and I just want to list all of my users. Well, I used to have 3, but now I have 2. Well, at least from the perspective of the consumer. But as we know, I haven't actually deleted this other user. I just flipped deleted to true. And we will look at that filtering logic as well. So it's just that's a personal preference. Some things maybe you want to remove permanently from your database. Personally, I think that storage is fairly cheap, so there's no real downside in my world to just keeping this information around, since it's already been deleted, right? Right, so these are the base tips that consistently produce, in my world, quite a lot of useful, like good results. And I will also touch on like this thing here. Now, one thing that a lot of people do, which I don't really like, is that they have this, that they have different places where they handle their errors. To me, that isn't really the best thing in the world. What I prefer to do is to have one central location that handles, especially Node, that handles all of these error cases. So what I do is that I create this single point where all of my errors are actually handled, and if I want to express different types of errors, I simply throw them from an arbitrary position, but I never try to log out or send a response as part of, say, an endpoint, like an action handler like this, because when the system gets really large, it's very easy for you to have like a nested method that somewhere deep inside the code does some, like, handles the error and then like either swallows it or logs out one part of the error, and then higher up you forgot that there's another error handler that is going to log it out as well. So all of a sudden you're logging out multiple errors, or you're tracking multiple errors when there was really only one. It's just because you have multiple places where error handling logic occurs at the same time. This is very common in large systems. So what I like to do is in Node is that I create this catch exception handler, which is just a higher order function that takes a function and that's going to just return a function that takes in the request, the response, and next. It wraps all of that in a promise resolve. Basically, it returns a resolved promise where we simply call this function with all of those inputs, and then it has a catch afterwards, which is going to take the error and call next on it. And in Express, if you do that, if next is called with an error, it's going to hit the this error case here, or this use case where I have a middleware that simply handles the error. And this error, I just log out into my container so that I can log out the whole thing in my own cluster or my own cloud solution or whichever hosting solution you're using, so I can see the stacks and all that stuff when I go into the logs. And then I have this thing here where I should make a status check on the error.status code. Now this is not native to error. So what I'll do is that I create this custom error with status code, which extends error, takes in a message and the status code. So the message is just going to be, this is just an error, it's just a regular error with this status code property on it, so that I can, if let's say that somebody wanted to, I don't know, now, I have no validation logic here, so anybody can update any user, but maybe I don't want everybody to be able to update any user. Maybe I just want the user who owns this user object to be able to update this user. So if somebody else tries and they're not allowed to, I could throw an error with a status code of, say, 400. And then this would be caught here, and the status code would be 400, which is more semantically correct because you or 401 unauthorized, if you will. If that happens, you want to return the correct status code. But if there's no status code, then it's probably just a library or a coding issue on my part. It's not an explicit error that I have set a status code associated with, and then I just want to show return a 500 as the status because something crashed on the server, right? And then finally, we return only the error message to the consumer, because you don't ever want to return a unformatted message. Like, even this is a little bit bad because this message could hold like sensitive information about my system. So maybe like if I had a user-facing thing, I would change this to just say, hey, there was an error, we don't know why, or I would have some type of mapping logic or some type of filter that made sure that I don't leak like sensitive system information to the client, because you don't want to tell the consumer more than needed about the system problem. You just want to give them some hint that something went wrong. Cool. So these are the base ideas. We can actually just dive in a little bit in the services here. So we can see here that I have a user model and I have a service, and then I instantiate that service for convenience purposes. And then let's just look at the user models. As you can see, this is a very small Mongoose model. And here is my service, because I promised that we were going to look at this as well. So create user, nothing fancy here. All it does is that it creates the user and saves it. And then we have this thing here, which is called lists users. As we saw here, it just have some defaults like offset limit and fields. And then we simply go and find all the users that have deleted false, which was as I showed you earlier. This is the same thing as saying that, hey, don't only grab the things that haven't been deleted. And then I have these two queries here, skip, and that's set to my offset and my limit. And this is Mongoose specific. It's not like any API library that you're using to access a database will have something of this nature where you can skip a certain amount of data sets and set a limit for how much you want to return from the database. And then basically all I do is that I return like this array of users, I convert that to an array, I map over it, and then I have this little helper method that is called extract fields, which all it really does is that it goes through the fields that I pass in and simply pluck off each of the fields that I have specified from the user object, create a new object, and return that. And that's why I could support, as I showed you earlier, you can just, without having to specify the specific fields, you can actually just support that, all right, that you set any value and it's just going to grab the values that are there. If you're giving it something that it doesn't expect, let's say that I say fields equal to underscore ID, all right, so I'm getting the ID, but let's say I get foo as well. Well, then that there is no field called foo, so we don't, it just handles it. But you have to, as I said before, it's really important. If you had, let's say that you had a password, let's say that we actually had this thing here. So let's say I did this. Maybe I didn't want to leak that information. Maybe this was sensitive information. If I said, say, password here, it's really important that you don't allow, you have to validate, guys. You have to be really careful about not leaking this sort of information. So if somebody had something like this, you would have to go into your little function here and filter out, like go and like just before you do that, filter out all the sensitive information from the model so that you can't like specify in this extract field method or pass in a fields array that contains fields that are sensitive. So just remember that. That's on you. That's a personal responsibility. As a good programmer, you should think about that. And then we have get user, and it's very similar to this one. It's just that it grabs a single user and extracts the field from user. And if field is empty, hey, it's gonna just return the whole user thing or the whole user object. And then we have update user, which is, as we saw earlier, just a way for you to say, hey, I have some stuff that I want to update. I just gonna empty my trash like that. So basically all that you see here, like I'm just checking if I have specified these different input parameters, and then I update them and then I return. And this is the way that I make sure that nobody's just passing in arbitrary values and just saying that, hey, update password to that or update this to that. Always be explicit when you make an update. Make sure that the user first and foremost has access, like that you allow that update to happen. And the second thing is that you never ever allow them to just specify whatever they want to update. You have already decided that these are things that are okay for you to update so that they can't do any harm. And then delete user is, you know, instead of deleting it, I simply set deleted to true, and then I save and I return that object, and that's about it. This is fairly, like, this is in more or less the way that large-scale systems can handle REST APIs, and it's something that I use quite often, this way of working. So finally, we will touch on basically a little bit of this is a common thing, like what I've shown you so far is the basics of making a RESTful or a REST-ish API. And it's going to have you covered for a lot of cases. But I want to touch on one final thing, and that is that in production and like in real world software development, it's very rare that you can just keep everything this clean. It's very rare that you can just use the verbs and some basic base endpoints to express all the things that you want to do. Sometimes you want to do something that hasn't really to do with changing the model or just getting the model. Sometimes you want to express something more complex. Let's say that you wanted to send an email to a specific user. Well, how do you express that in a RESTful way? Well, it's really not part of the RESTful, like REST in essence, but you still want to do it. And the two most common ways I see this done are these two ways. So this is probably the thing that you will be most, like, will feel most accustomed with, and it's something that happens quite often in production where, all right, so you have the same endpoint, you specify a specific user, but instead of, you know, ending it there, you add another slash or another part of the endpoint that simply states the command that you want to execute. So in this case, I would just want to send an email. And, you know, I didn't add any email sending logic. I hope that's still clear. So you can actually use just the path of your URL to express the different operations. That's one way. Some people criticize this and say that it's not RESTful, and to a point I can agree, but I'm a pragmatist, so it does scale. There's nothing wrong with doing this. It's very common, and I use it every day in work. I mean, large-scale systems are rarely, they don't really have the luxury of always being zealous about everything. Anywho, the other approach, which I also think is very nice, is if you want to keep your URLs clean and not have to like have all these different endpoints, you can do something like this, where you specify a command as part of your query, and then you simply have a switch statement where you check the command and you simply execute or call whichever service method or whatever you want to do as part of that. If this is supposed to be working, especially if you have a really large system, it's very important that you use something like this where you abstract away the actual implementation of executing the command. So you really want each of these cases to be just a one-liner if possible, because you're basically taking this thing here and putting it all into one single action handler. And that can get really messy over time if you have a lot of different commands. But yeah, these are the basic tips I can give you for how to achieve success with a RESTful API. It's very easy to, like in my experience, this is very flexible. It's very easy to maintain, and you can extend it quite a lot if you wanted to. So I hope you found this useful. Have a great day.